Good day, our dear learners. We are your team teachers, and for today's discussion, we are going to talk about radicals. But before that, let me check your attendance first. Who is not around in our class today? Wow! Everybody is around. Class, let's give ourselves 5 claps for the perfect attendance. So now, what motivates you to attend our class this day? Okay, Miss Anne, you're raising your hand. Wow, that's great. Thank you for sharing, Miss Anne. Class, before we proceed to our discussion this day, allow me to present our learning objective first. So, at the end of the lesson, the student must have: first, determine the laws and radicals. Second, perform the operation and radicals expression with speed and accuracy. Third is to develop appreciation on the application and the laws of radicals in real-world problems.
Okay, before anything else, we're going to have some fun while practicing our radical expressions. We're going to play an augmented reality or AR hunt game. Here's how it works. Okay, so I'll divide you into 5 groups. Using your smartphones, you will scan the digital QR code that I'll share with each group, which will link to radical expressions or AR activities. Your task is to simplify the radical expression and enter your answers into GeoGebra AR to visualize the radical graphs and confirm your solutions. The first group to confirm that all their answers are correct will win. Any questions, class? If there's none, let the game begin. So here's our first QR code for each group. On the count of 3, you will all start in 3, 2, 1, go! Alright, group 1 is fast. They've already scanned their QR code and started simplifying their first radical expression. And group 3 is trailing group 1. Wow! Wow, group 3 is trailing group 1. They're catching up real quick. Okay. Group 2 and 4 are almost there. Go, go, go. And alright, we have our winner. Congratulations. Group 3, their strategy of dividing their work and checking their solutions together helped them beat group 1 at the last second. Okay, class, settle down.
Good day, everyone. Welcome to our discussion on the laws of radicals. I hope you're all ready to engage in an exciting session of learning. Today, we will revisit the basic concepts of radicals, explore their properties, and apply them to simplify and manipulate radical expressions. We'll also discuss real-life applications and problem-solving techniques. Before we dive in, let's quickly recall, what is a radical? A radical represents the root of a number, such as square root of 9, which is equal to 3. Radicals are closely related to exponents. We can express them in terms of fractional exponents using the properties a to the power of m over n is equal to the n root of a raised to m. Additionally, we have important radical rules such as the product rule, the quotient rule, and the power rule. Radicals appear in physics, engineering, and architecture. For example, in engineering, they are used in Pythagorean theorem calculation. We learned about radical properties, operations, and rationalization. These are essential for simplifying expressions and solving equations.
Good morning, everyone. Today we're going to explore a crucial part of algebra, the laws of radicals. Radicals, often represented by square roots or other roots, are a fundamental part of mathematics. Working with radicals can seem complex at first, but understanding the laws that govern them makes it much easier to simplify and manipulate expressions. Let's start with the product rule. Square root of a times square root of b is equal to the square root of ab. This rule helps us simplify expressions when we multiply two radicals. It says that when you multiply the square root of a by the square root of b, you can combine them into the square root of the product of a and b. For example, if we have square root of 4 times square root of 9, using the product rule, we can simplify it to the square root of 4 times 9 is equal to, that's right, square root of 36. And square root of 36 is equal to Very good. 6. Now, let's look at the quotient rule. This rule helps us simplify expressions when we divide one radical by another. It tells us that when we divide the square root of a by the square root of b, you can rewrite it as the square root of the fraction a divided by b, as long as b is not 0. For instance, if we have fraction square root of 16 divided by square root of 4 using the quotient rule, we get the square root of 16 over 4 and it is equal to square root of 4, and square root of 4 is equal to 2. Very good. Both of these rules are essential for simplifying expressions with radicals. Remember, the product rule helps us combine radicals when we multiply, and the quotient rule helps us simplify when we're dividing as long as the divisor is not 0.
Now let's continue with the power rule. This rule helps us simplify expressions when we have a power outside a radical. So it says that if you have a root of a raised to the power of m, you can rewrite it as a raised to the power of m divided by n, where n is the index of the root. So for example, if we have cube root of x to the power of 2, using the power rule, we can simplify it to x raised to the power of 2 divided by 3. So this makes it easier to work with expressions involving radicals. Now, let's proceed to the simplification rule. So this rule helps us simplify expressions when the power outside the radical matches the index of the root. So it tells us that if you raise a root of a to the power of n, where n is the index of the root, the result is the absolute value of a. So for instance, if we have the square root of x raised to the power of 2, using the simplification rule, we get the absolute value of x. So this rule is useful because it helps us eliminate the radical sign when the power matches the root's index. So both of these rules are important tools for simplifying expressions with radicals. Remember, the power rule helps you simplify when the power is different from the root's index, and the simplification rule helps when they are the same.
With the same group, let's have another activity. I will be providing you 5 illustration boards, one for each group, and chalk, so that we'll be having our MTOP oral challenge. So here's the mechanics. I will be reading the question and you will be timed for 15 seconds, and after 15 seconds you must raise your illustration board regardless if you have answer or not. The group with the most score will be considered a winner. Okay, so are you ready? Let's begin. Square root of 3 times the square root of 100 divided by 30. Your timer starts now. Okay, time's up. Raise your illustration board. Okay, group 1 got the correct answer. Only group 1 got the correct answer. Number 2. Square root of 36 divided by square root of 16. Again, square root of 36 divided by square root of 16. Your timer starts now. Okay, time is up. Raise your illustration boards. Okay, group 1 got the correct answer again. What is the cube root of 216 squared? Your timer starts now. Okay, time is up. Illustrations boards up. Okay, group 2 and group 3 got the correct answer. How about number 4? What is the square root of 100 squared? Again, what is the square root of 100 squared? Time is up. Raise your illustration boards. Okay, only group 1 got the correct answer. So congratulations to group 1 and to everyone for participating in this activity.
Great job, everyone! To wrap things up, let's watch a short video that connects what we've learned today. After the video, we'll have a quick discussion to share our insights.
Hey there, it's Dr. K with Infinite Magic Productions, and in today's episode, we're going to learn about how we can apply radicals to everyday life. Now, mostly when you think about radicals or square roots or cubic roots, I guess you just think of a boring old algebra textbook, but it doesn't really have to be that way. Radicals in everyday life are used, well, every day. So The easiest example of a radical that we can think of in everyday life would be to figure out, for example, the surface area of something. Let's say you're building. We can make this example slightly more difficult, and let's say we have something with a volume. We'll have a cube. So let's say you want to build a house, for example, and the house is going to have a certain volume. So from this volume, you're going to want to figure out the surface area of the house. So you want to know how tall you can build the ceilings and how big the house is going to be in terms of square footage. So here, we're going to take the cubic root of the volume, and that's going to give us the length of one of these sides. And when a tree grows, here's a tree growing, when it branches from the main trunk here, this is the main trunk, this branch is going to have the volume or the surface area of 3/4 of the main trunk. So if the main trunk has a volume of X, this tree limb is going to be slightly smaller by 1/4 power. So your main veins that are going from your heart have a very large volume or surface area, and when they branch out into your arms or even smaller to bring blood to your cells, they're going to get smaller and smaller, and every time that they branch out and get smaller, they're going to get smaller with the radical of 3/4. The way that we grow, the way that nature behaves, is actually a radical expression. So go out there to nature and think about it. There you have it. That's how you can apply radicals to everyday life.
This video helped reinforce how radicals and exponents are connected. Understanding these concepts will help us simplify expressions and solve more complex problems. We've explored the laws of radicals and how they help us simplify mathematical expressions. But why is this important? Let's take a moment to reflect. Radicals are everywhere in real life, from measuring distances to engineering designs, even in financial calculations like interest rates. Mastering radicals makes problem solving easier and more efficient. Now, can you think of a situation where knowing the laws of radicals would be useful?
Okay, now we are done with the activities and discussions. Now let us proceed to the quiz. This quiz will not be the usual quiz you know. We will utilize Kahoot. This will make the quiz more exciting, more engaging, and more challenging. Here are the simple instructions. Questions will be posted on your screens as well as the choices, but your time in answering will be limited. So the faster you answer, the better. And scores will be recorded after this quiz. So let the quiz begin.
So as for your assignment class, solve 5 problems involving laws of radicals. Show step-by-step solution for each item. So after that, create a digital ICT tool to post your answer or make a video presentation about it. It might be PowerPoint presentation or any other type of ICT tools. So include also the explanation to make it clear. So for submitting your assignment, make sure to post or copy a link of your posted video presentation for that. So that's all, class. Have a nice day.
For today's discussion, we talk about radicals. And of course, we learned the product rule, quotient rule, power rule, and of course, the simplifying radicals. In conclusion, understanding the laws of radicals is essential for working with radical expression in algebra and beyond. As we conclude our discussion this day, I encourage you to continue practicing and applying these rules to reinforce your understanding. Remember, mastering the laws and radicals will help you tackle more advanced math concepts and solve problems with ease. Thank you for your attention. Thank you for attending this class. I'm looking forward to meet you on our next meeting. Goodbye, class. And class dismissed.